Hello, I'd like to welcome everybody back to your second music theory. I erased it, dang it. Music theory tutorial. So, in this video, I'm going to be talking about sound a little bit more, and I addressed it in my first video, but that was just to kind of introduce things. So now I'm going to go a little bit more in depth. So, sound, as I said, is a vibration. Your vocal cords in your neck. Oh my gosh, look at how huge that Adam's apple is. Whoa, that's just disgusting. But anyways, vocal cords in your neck, throat, whatever, vibrate, and that produces sound in a way. Now, how this works is it doesn't actually produce sound. This vibration travels through the air and then hits our ears, which interprets the vibration as sound. Hopefully that makes sense. Let me draw this out a bit. Get my marker here. So, here we have a guy, and he's screaming, and yeah. So, he's yelling at this kid over here who has an ear. Yeah, that's his ear. Man, I'm a good drawer, aren't I? So, this guy talks, and there's like this little vibration, and it travels through the air and hits this guy. Now, the reason this works is there's molecules, or basically just little tiny dots, that's just pretty much in the air. And what this does is it will hit these molecules, and the molecules will hit the next molecules. And then these molecules will hit the next molecules. So, it's not, these molecules here are not traveling and hitting his ear. These molecules are hitting these molecules, and these molecules hit these molecules, which hit the next layer of molecules, which hit the next layer of molecules, which hit his ear. And there's not really layers. They kind of just spread out, sort of like an ocean of these little dots. You don't really need to get into that really much. Just think of it as a wave, because sound doesn't travel like this. It travels in three-dimensional space. So if here's the front of the guy's face, here's his teeth, here's his face. The sound travels this, like this, and out this way. So it's like, boom, like everywhere. But it's mostly effective to where you're pointing your mouth, because that's where it'll push forward to reach the other person's ear. Now if we study this vibration a little bit more, there's two stages. There is compression, and then there's something called rarefaction. So basically think of molecules, this vibration is pushing these molecules this way. It's going to, let's say there's a layer of these molecules, and they hit this layer of molecules. So this layer of molecules is going to push forward. Now it's here, it's going to come back. So it'll be like bam. So it's like, I don't like you, and it's like bam, bam. You know what I'm saying? And then this is going to do the same thing to this layer and this layer. So the first is called compression, because these become closer together, because this layer here, if you can even see that, hits the other layer, or just like kind of all of these like crunch together. That's called compression. And then they kind of come back as these continue to go. So it's like bam. See what I'm saying? So it compresses and then it rarefies. Now this is very important because sound is a vibration essentially, and there's two stages: compression, rarefaction. That's why we get a graph. This is called a sine wave, like this. Now if you look at this closer, here is it compressing, here's it rarefying. Compressing, rarefying, compressing. It's not just one direct wave. It's not like wah, it's like wah, wah, wah. So it's like wah, 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 like dubstep, you know? So all sound is a form of dubstep, you know? Not really. But anyways, that's important. So when we're calculating the frequency, which is how fast something vibrates, we have positive, negative. That is considered 1. So if we have this wave that goes like this, let's look at this. We have 1 here one here, and then a half of one. So this would be like 2 1/2. Make sense?